Hi and welcome to my channel. My name is Joshua from Tag. In this video I want to provide the second part to the previous video we had on the usage of the for loop in our programming. So before we get started with what we have for today, let us have a recap on what we did in the previous video. So I'm going to start by creating a variable called vec, and I am sampling from observations ranging from 1 to 10, and after these observations I'm interested in just 5 samples, and then with replacement assign this to be true, and then I run and I have the value 43515 stored in the variable vec. So to apply the for loop, this is what we need to do, like we did in the previous video. For I, the index value for I in the variable name vec, and then the simplest thing you can do is to write the expression print I. So what are we doing in this case is the I stands for like the index, that is observation 1, which is 4, print it out, go again into the loop with observation 2, print it out, go back into the loop 5, print it out, go 1 till we get to the last value, which is 5, and then it prints it out. So if I run this, we're expecting to have the same value 43515, but this output is not reducible, and we would see as we go in the video how we can make the output of a for loop reusable. So at the same time we can also have like for I in vec, and then easily I can say print. I can have I can combine my result. I can say I comma I raised to the power of 2, and then I can run this result, and the value for I is 4 raised to the power of 2 is 16, the next value 3 raised to the power of 2 9. It goes again to the next value we have in variable vec 5, it brings 5 into the loop, this is 5, and then this is 5 raised to the power of 2, we have 25. It continues until it gets to the last value in the variable vec, and then it takes the square of that variable. So we also agreed the last time in our previous video that it is possible for us to create a variable inside the for loop. So for instance, we have like I'm creating a variable and I'm saying this is storing the result of I, the observation raised to the power of 2 divided, divided raised to the power of 2 divided by 3, and so you say print, and then whatever the value of that expression is, we're expecting to also print it out. So if you run this, you have this particular result, and it follows that same way that we have established. So there is one interesting thing, an example I want to bring out that is also very important, but to come up with this example, let me use okay, let's just create a new variable again, still vec, and then we just want to have some bit of minus 2, 5, 1, 3, and 4, for instance, and then we have this. So it is also possible for us to still use a for loop to say for observation in vec, let me space it down very well, in vec, and then we have a curly bracket, and then we put whatever expression we want inside that curly bracket. And so I still want it to print. Let's take for instance I'm combining the result of I and I, let's say I plus 2 for instance, and so if I run this entire thing, I'm expecting to have this -2, and if you add 2 to -2 you have 0, and then this is 5 plus 2 7, 4 plus 2 we have it as 6. So we have been, the last time I said something about we interested in making use of the result of the loop statement. So how do we do this? Now we are going to introduce, I'm going to introduce to us a concept like a counter, and so we are going to use both the numeric counter and the categorical counter. So in this case, let's take for instance that we have we want to store, let's say 4 for instance. Let's have this simple example, observation I in vec, and then we just want to say print I raised to the power of 2. So how do we have the values that have been printed 4, 25, 1, 9 and 16 in such a way that we can reuse them again? So what we mean is that we want to store them in a variable that can be useful again. So to do that, let's have a numeric counter, and I'm going to call these scores. For instance, let's say scores, and then I'm saying scores because we have like 5 observations. I'm creating 5 empty numeric values, and then I run this. So we have a variable as scores. So let's see the way to do it and the way not to do it. So it is possible for me to, now before we go into that, I just remembered it is important to also have this understanding. Let me bring it back to our notice. If I run vec, this is what we have as vec -2, 5, 1, 3 and 4. So don't forget this concept of indexing using this square bracket. So if I put 2 here, I am interested in the value in position 2, which is 5. So peradventure, if by mistake what we have as 5 is not meant to be 5, let's take for instance it's meant to be 3, so I can change it. I can change this and call this 3. So if you check vec, you will see that the value now has changed to 3. So don't forget these two things I've just done. First indexing, and the next is replacing that value that we have. That is the concept of replacement. We've done this like in the first like series of the first videos I uploaded. So now this particular concept is important for us to have a good understanding of how we can reuse the output of a loop function. So having done this, our interest is to store this particular thing inside this variable called scores that currently is storing 5 empty numeric values. So yes, I'll leave the value of vec to be what it is, which is -2, 3, 1, 3 and 4. And now so we want to have like that same thing again. We already have an empty variable called scores, and then I'm going to say 4. Now we will learn how not to do it and how to do it. So for I in vec, and then my interest is for observation I in vec, store whatever result you have inside score. So let this be for the first observation inside score. Now let it be, let's say, assign, and let it be I, as in that case print I raised to the power of 2. And so let's see what will happen. So we notice that on the global environment now we can easily print scores. So scores is 1, 0, 9, 16 and 4. So one thing you can notice is that this result is not consistent, it's not coherent. And so this is the wrong way to go about a particular concept if we are interested in printing out a usable value of our loop output. So the best way to do it to save time is to say for, and then we have I. Yes, we have I in 1. So let's say the length of vec, and then I have the curly bracket. Let me give this much space. Good. So and then I can come and say scores. So the scores for the first position, let it be this. Let it be the result of this expression. Let's put the vec, that is the first value in vec. Take it to the power of 2, and then this will give us the exact thing we are interested in doing. So let's go and confirm. Let's have vec, let's have print vec, and then vec to the power of 2. Let's see. Oh, my apology. Let's have okay, let's just have scores and compare it with vec. This is scores, and let's have vec. So you could see this is minus 2 raised to the power of 2, 4, 3 raised to the power of 2, 9, 1, 9, 16. So this is the best way, the best approach to like go about it. So we've learned how we can actually store and reuse the output of a loop function that has to do with numeric. So for instance, I remember in the last video we did something on having the output again using loop to have a value that is either even or a value that is either odd. So for instance, let me go again, in a simple way so that we can have this understanding, because when we have this understanding, everything again in R that has to do with loops becomes very easy for us to understand, no matter how complex the code may look like. So if I run this, the value of our vec is still minus 2, 3, 1, 3, and 4. So now we want to write a code that will tell us if a number is even or if this other number is odd. So we're going to say for I in vec. Now you put your curly bracket and then you space it down. Now we specify a condition if, and then you put the condition in the bracket. Now you say if I, the division of I by 2 gives us the remainder of 0, then what do you want to do? You put this particular thing. You say, you could use the print function, or you could easily say even. So but let's just say print even. So s print odd. So if you run this entire line of codes, you could see the first value that we have in the variable vec is minus 2, so it is even. The next value is odd, the next is odd again, the next is odd, and the last value is even. So how do we do this now? How do we store these outputs in a variable that we can always use again, just as we did in the case of something that is numeric? How do we do it for things like this that are categorical in nature? So let's go about it. We also create a counter. Let's take for instance that we want to say this is like a class, but I'm not going to use the word class because it is a unique function in R. So I'll just say CLX in this manner, CLX, and I'm going to say this is a character counter. So I'll say character, and in this case I can choose to use 1. Let's see, because character has a way. If I let me check the class of CLS, will give us character for sure, so it has a way of expanding itself by default. We would see an example for ourselves. So now let's take for instance that we now want to go over this again. Now the wrong way to do it would be if you go by saying for I in vec, and then you have this, you can space this down. Yeah, let me space it down again. So for I in vec, if you state the condition if I divided by 2 gives a remainder of 0, then what do you want to happen if the particular condition is met? So I'm going to say CLS, the first observation to be stored in CLS would be the result of this particular expression. So in this case I'm not even using print function, I just want to write even, and then I say X. I'm going to say CLS again I, and then let's say odd. Yeah, so if it is not even, definitely it's going to be odd. So I'm going to do something for us to see the way arrow come out with its result. So I'm going to say print CLS here, CLS, and then let's run this entire line of code. Now we could see what is going on here, because this is the wrong way to go about this whole thing. You see, the first thing that happens is that the observation that we have here, it tells us that this is even, and then it goes again and we have some missing value. I won't go deep into explaining how arrow generate this particular output, but one thing I'm going to do in this tutorial is to tell you the right way and the wrong way how to go about writing your code, especially when using the for loop in arrow. So let's go with the right way to do this. So we have done this when we were using the example of the numeric. So I'm going to say for I in 1 to the length. So we use length when we want to see the number of observations we have in a vector variable. So we have length is a function, and then you include the argument. What are we looking for? Vec, which is -2, 3, 1, 3, and 4, and then you say impute the if conditional statement. If, now you would not say I as we have in line 56. Now you would say we have this variable vec, and then you pick the first observation in vec using this particular thing, and then you'd ask that particular question if the observation that we have first in the variable vec is divisible by 2 and it gives a remainder of 0, then what do you want to happen? Then I can easily say store that particular result as even and store it in CLS first observation, and then let's have even, and then S CLS the first observation as well, then use odd. So I'm going to say print, still inside the loop function, I'll say print CLS, so we can see how R come about this particular result. So let me go again and rerun the counter so it has an empty character. So good, and then I go over to my for loop from line 63, and then I run this. So this tells us how R performs this. So arrow goes into the loop. This is for I in 1 to length of this particular thing. So we know this is -2, and then it takes this, that is the vec in position 1. In this case, this is I, length of vec, if we run this code alone, length of vec is 5. That is, we have 5 observations. So we are saying 1 observation 1 I in 1 to 5. So it starts with 1, enters into the loop. This is vec of 1. That is, the first observation we have in the variable vec is -2, and the remainder gives like -2 minus this. It doesn't give like a remainder, it gives 0, yeah, because we have it as -1. And so then it talks, if that particular thing gives a remainder of 0, then classify it as even, else classify it as odd. So the first is even, and then it stores it inside this empty character variable called CLS. It goes again into the loop, not with 2, this time around with 3, and then it goes into this particular place till it gives a remainder of 1. So it will not classify it as even, instead it will use the value odd and add it, paste it to the one value we have in the CLS variable, and then we have even and odd, and then it goes again with 1, it provides odd, add it to the existing values we have, it goes again to 3, which is odd, add it, and then finally it goes to the last one, which is 4, and add it as even. So if you run the value CLS, you would see that now the result of the loop has been stored in a variable called CLS. So I want to believe by now we have a good understanding of how to use the for loop function in our programming, and I would advise that we apply this to whatever field of study we find ourselves. And in the next part of this particular series, I'm going to create a quick example on how we can apply this to some basic calculations in biological statistics, biological fields, and you can take an example from what we've done and apply it to your fields too. Thank you very much for your time and choosing to learn with me. May God bless you. Do have a great day. See you in the next video. Bye bye.